Hi, welcome to the Signal Pad. This episode is all about my new 3D printer, which is the one sitting right over here. Now, if you're in the market for buying a 3D printer, you know that there are so many different models available across a wide range of prices. So my requirements for a 3D printer were pretty straightforward. I wanted an easy experience. I didn't want to have to fill in any parameters or try 100 prints before I get something right. I just wanted a plug and play type of machine, but it just works right off the box. And I also wanted something where I can just plug and unplug cartridges of filament into it, and it would know what kind of filament it is, get all the parameters and configure it itself, and just print right out of the box. I also wanted something that's enclosed because ABS smells pretty bad, so I wanted something that has a nice fan and a filter built into it so that the smell doesn't get into the lab and into the house. I wanted a webcam, I wanted lights inside, I wanted a really advanced firmware, I wanted something with the Wi-Fi. I had a long list of requirements, and I looked around. I spent quite a bit of time until I found the Sindoh 3DWOX 1. Now this has been working really well for me. I've had it for quite some time. I've done many different prints on it, and I wanted to tell you a little bit about it. Now, one of the main reasons why I wanted this is because I wanted to see if I can print microwave components and microwave components at millimeter wave frequencies. So I actually have done some of those experiments too, and at the end of the video, I'll show you how I've done some 3D designs of some of these microwave devices, and we're going to actually measure them. But I did want to tell you about the printer so you can see how it works and show you some of the different things. I even x-ray some of the things I've printed because I wanted to see how the printer deals with internal structures, because that can be pretty important even though you can't really see it from the outside, especially if something is load bearing. So we're going to even x-ray the parts that come out of the printer. There's a lot of interesting stuff. There's going to be links at the bottom so you can jump to a specific place in the video if you want to, but I'm really excited. Let's go and take a look. So on the Sindoh website, you can see the couple of different printers they offer. Now there's the 3DWOX one, which is what we're going to look at. There is this one, which has actually two printing heads, and the DP200, which is a slightly older model. There's a lot of information and useful documentation on their website. I'm not going to go through the detail, but I just wanted to show you a couple of different printers they have. The one with the two printing heads is actually really interesting if you want to take a look if you need something that advanced. But for now, we're going to take a look at the 3DWOX one. And here we have the Sindoh 3DWOX 1. As you can see, it's a really nice looking printer, and it's a fully enclosed unit, and there are major advantages in having something that's completely enclosed, and I'll talk about that. The unit dimensions are about 17 cubic inches. It's a little bit bigger than 17 inches in one dimension, but it's about 17 cubic inches. The active print area is also about 7.9 cubic inches. So the printer is quite a bit larger than the active print area, but that's to be expected because it has everything included in the printer itself. You're going to get the cartridge directly inside the unit as well. The front and the top doors open, and you can have these open while the printer is printing. The advantage of having something closed is, of course, nothing can interfere with the printer while it's running, so nothing can get caught in the filament and so on, and we'll see that while it's operating. This particular unit has a HEPA filter built into it, so if you're printing something that smells like ABS plastic, the HEPA filter completely blocks that, so this can therefore sit directly on your bench without any issues, and it's going to not basically put out this nasty air into the room. At the same time, because it's enclosed, it's going to be quite a bit more quiet. This printer is almost silent, except for the situations where it's doing a retraction, then it makes a bit of a noise. But other than that, it's really quite nice and quiet. There is a webcam directly underneath here and lights, which we will take a look at. And I want to show you the internal structure of how the filament moves around and how the cartridge is auto-loaded and how we have self-alignment and balancing and all that, which is quite nice. The LCD over here is a big touchscreen LCD screen which has all the settings, and you can configure the unit, and everything you would want is over here with Wi-Fi connection, which of course it has built in as well. It also has Ethernet, I believe, at the back, power USB, and a USB port in the front. So it's really nice. Let's go ahead, take a look inside of it and see how it works. And here's the look inside the printer. Now, the most important part in terms of printing is, of course, the print surface itself. And this is a heated bed, as to be expected. Of a printer of this caliber is going to have a heated bed. And the bed is magnetically connected to the floor of the printing area, which means that you're going to have a magnet which is as big as the entire print surface. And this is important because once you put this plate back on, you're going to get a uniform flat adhesion to the bed itself, and everything is thermally coupled, so you're going to get the temperature transferred directly to the printing surface. This is flexible, like so. You can bend it in both directions, and the advantage of that is of course, you're going to be able to have your parts once it's printed. You don't have to wedge anything underneath it. You can just bend it and it just snaps off, and that's really helpful because you get the best of both worlds. You get really good adhesion, which is what you want, but you're not going to have the trouble when you want to remove it from the bed surface itself. And once you're done, you just put that back in there. Yeah, snaps up right and easy, and it's got silicone handles so that the temperature doesn't hit your hand when you touch it. There are 3 stepper motors inside, and the 3 stepper motors are responsible for the X and Y and Z directions of movement. Of course, everything is belt coupled on metal rods for alignment and everything, and it works really well. Reliability is quite good, repeatability is quite good, and we will see that with the print examples I have prepared later on. Now, if you look at the design of this, you also have 2 rods over here which are coupled together with a belt, and 1 stepper motor there, and at the same time over here the print head at the top as well. This looks very much like an inkjet printer, and that's not surprising because Sindoh, their original expertise was in inkjet printers, and that's what they used to make, and they're basically transferring that technology to 3D printing. It's a natural evolution of their technology. So they have quite a bit of expertise building these things reliably and repeatability, which we want from a 3D printer, just like you would want from an inkjet printer. The print head itself is fully enclosed. It's got double fans. It heats up really, really fast. The nozzle has a self-cleaning mechanism. There is a little compartment here which is removable, and once the nozzle heats up enough, it parks itself to the right. It extrudes a bit of filament, and then it cleans itself against the edge of this, and everything falls in here. You can see a little tiny piece already in there from the last print I did. Every once in a while you're going to have to clean this, but you never have to worry about filament hanging from this or falling into your print or having a poor initial start as a result of filament extruding where you don't want it. It's all self-cleaned and handled automatically. So I'm going to put this back over here. And we're going to see the bed leveling algorithm that is built into it as well. We're going to see how that works. And this is where the cartridge goes. So let's go ahead and take a look at the cartridge, see how it's built. And then we'll load it in there and we'll see the exact procedure to get the printer up and running. And we'll see how easy it is. And here is the cartridge. Now this cartridge is made by Sindoh, and the filament is made by Sindoh as well. If you buy the ones that are manufactured by Sindoh, you get a couple of advantages. It just becomes plug and play. And the reason for that is because there's a chip here, and this chip stores the information about this filament, all the characteristic that it needs to transfer to the printer. It also stores how much of it has been used. So whenever you put one of these cartridges in, the printer knows how much filament is left in it. And it can tell you, for example, if you have enough for a particular print, and it can pause the print and then you can remove it and put another one, and so on and on. So the advantage of that is huge. But the printer is completely compatible with third-party filament. It's not locked to any particular manufacturer. You just don't have all the setups and settings directly transferred to the printer. You're going to have to enter those yourself, but that's not a big problem. I'm just going to stick with Sindoh filaments because I just want something easy and ready to go. So now we're going to have to go ahead and put this directly into the printer and see what we have to follow to get that up and running. Let's see how easy that is. Okay, let's go ahead and try and load the cartridge into the printer. So first, I'm going to actually insert it. There you go. I'm going to put that in here, like so. Very easy. Close that up. Let's go ahead and see how the printer handles that. There you go. So it actually automatically detects it for me. I don't even have to go through the menus. Do I want to load it? Yes, I do. And then it's going to feed the filament initially into the printer. So the head is being retracted over there, and it's just going to go through the procedure. Now it needs to heat up the filament to a particular temperature, and in order for it to be able to feed that, so it's going to go through all the stages to do this. Let's wait a couple of seconds to see what happens. All right, here we're the second stage, and you can see how fast the head warms up, which is really quite good. So it really doesn't take that long to reach temperature. And once it hits 210 degrees Celsius, then it's going to be comfortable for it to push through, and it's going to extrude a bit of extra filament in there, and then clean the nozzle, and then it will be all ready. Here we go, 210. It's just doing the last filament insertion now, and it's going to be done any second. There you go, loaded and ready to go. That was it, and it's just as easy to remove it. If I go under cartridge over here, I can just go unload, and I can just take the cartridge out after maybe about 20 seconds or so. Especially if the printer is hot, it will be almost instant. So it's really easy to get that up and running. Now once you have the filament in there, the next thing you want to do is to level the bed. So we can go ahead, go under settings, and under settings you have quite a bit of options. You can set up the Wi-Fi, you can do offsets, you can clean the nozzle, all the other different menus. You can see quite a bit of functionality built into this. I don't want to go through all the menus because I think that would be kind of boring, but really very straightforward. Look at how many different things you have in here. You can go through and figure all of that out. You can have it send you emails and messages when it's done. You can do a test print. You can load everything from the front panel, every setting you can imagine. Anyway, let's not bore ourselves with that, and let's just do a bed leveling, which is this option. So now it's going to first measure to see how good the leveling originally is, and if the leveling is sufficient, you don't have to take any action at all. But if it's not, it's going to ask you to do some leveling. Now on purpose, I have unleveled the bed so we can see what happens when it goes through the entire procedure. So it must make sure that there is no printed object in the way. There isn't. Now it's going to go through the bed leveling. Let's see what it does. So I'm going to do some freehand recording here. So you can see the little nozzle it has that comes out, and it just barely touches it. This is not the same as the printing nozzle. It's another little sensor they have in there. So it makes a tiny measurement in the front. It's going very, very slowly, and then it's going to do 2 measurements in the front over here. There you go. And once it's done with that, it's going to give us some recommendation, and it's going to tell me how much I have to turn that screw or that screw on the right side in order to be able to get the bed level. So it's going to do 2 measurements, and it's going to give me a recommendation on the LCD screen. Okay, so it's figured out now that I need to turn this screw by 0.3 turns in order to get the bed level. Well, that's pretty easy to do. I can go ahead and do that. It's in fact this screw right here, and it's telling me to turn it clockwise by 90 degrees. So I would say that should be enough. So let's go ahead and say okay. Now once you say okay, it's going to go through and basically redo the measurement again. You can see it doing that. And it's doing that one more time. And let's see if my measurements or my corrections was good enough. And there we go. It was successful. That's it. Now we are ready to go. So now I'm going to go on the software. Let me show you how the software works, and we'll do some prints.
So let's take a look at the 3DWOX desktop software. Now this software is written specifically for the Sindoh printers. As a result, it has a direct connection and configuration from the printer, making it nicely integrated with the whole experience of 3D printing using the Sindoh printers. It also extracts information from the type of filament that's inserted into the printer and bringing all that settings into here. So in terms of features, it's reasonably well featured. It may not have as many tiny settings as something like Cura as a software, but again, you really don't need that because a lot of these things just works very well on the Sindoh printer in combination with their own software. But I will show you some of the settings you can modify. So here we have a unicorn that I want to 3D print, for example. I can go under the settings here, and you will find most of the settings that you would basically find with other types of printers as well. Pretty much everything you would ever need to play around with. So the profile here is Sindoh PLA because it knows that we're using a Sindoh PLA as a cartridge there. Temperature as a nozzle temperature, layer heights and everything can be adjusted directly from the profile basic page. We can also, under the quality and infill, change the way the bottom and the walls and the different layers are filled, especially with the infill pattern. And I'm going to show you exactly what that looks like with some of the prints we're going to do later on in this video. If you hover the mouse over anything, it will give you a full detail of what's going on. A lot of help is available if you are not sure about how to change these parameters. The speed of the print, of course, can be changed. It's a compromise between quality and how long you have to wait for different parts. Retraction and cooling is critical to get holes and objects that are very close to each other where the printer head is jumping back and forth between. These are interesting and difficult settings to figure out, but all the time I'm basically been using just a default. But if you ever run into any problems, you can just go ahead and change some of these settings. Multi-nozzle and so on is not enabled because this printer doesn't have 2 nozzles, but you'd have to purchase a higher model of the Sindoh printers to get multi-nozzle printing. And of course you can do shape error correction, and you can look at all the help files to see how they work. I don't want to waste too much of your time going through every one of these settings. In terms of support is critical, especially if you have pieces that are hanging over the bed plate, which it cannot print over the air, and you can add different type of support. I've been surprised of how well you can print without any support on this printer, and I'll show you examples of that later on as well. But touching the build plate is a very common way of creating support. And there's of course also bed adhesion. If you have an item that you want to print that has very little contact with the plate of the printer, then you want to create types of support that increases the surface area between the object and the print surface itself, and then which you later on break off and separate. Here I have it just wrapped, but you can do a skirt, which is the minimum you can basically apply. So let's go ahead and cancel this and just look at this object that we want to print, we can of course zoom in and take a look at it, and we can go and see what kind of support it recommends for something like this. Now this probably needs some support because especially here in this area with the belly of this unicorn is completely overhanging, so it has to have some way of supporting that during print. So let's go ahead and see what is chosen. There it is. You can see what it has decided to do. So let's move this down so we can see where the supports are. So here's the silhouette of each of the layer at the top. So this is the shadow of the object onto the build plate, and you can see it has decided to do fills in the areas it considers critical in terms of the angle of print. Well, if I don't like that, I can just delete them and choose to put them only where I want. So looking over here, okay, fine, I'll put something over here in the belly, I'll put something over here, and then you can remove them and modify them and move them around. So it's really nice to be able to change things on the spot, and the software runs really fast and smooth. I've had no problem with it at all. Then we can go ahead and create the layers, and there you go, and it's going to create a G-code, and here is our object, and you can see all the different layers. So I can go through all the layers from the top to the bottom, and you can also see how the print head moves. These darker lines are the path of the printer head, and you can see it has a fill of uniform honeycomb fill. Very nice, nothing unusual. And once you're done with it, all you have to do is click print, and it will send it to the printer. Really straightforward. Software is quite powerful, but at the same time, if you don't want to worry about the settings, just ignore them. Just load your object, layer it, print it, and it will come out of the printer. And this one will take 1 hour and 26 minutes printing from the cartridge we have. It's really quite good.
All right, let's start a print. And once I do the print on the computer, or I can do it from the USB port, it doesn't really matter. It sends it to the printer. And one of the things I really like is that it's going to show me a preview of what it's going to print. So if you have something and you have multiple things submitting to different printers, having that on there is really helpful. So it's going to start. I'm very excited. Okay, so all the information is displayed. The temperature is now 200. The bed is almost at 60 degrees Celsius, which is the default. We can pause or continue the print directly from the menu, and it tells you how long it takes. This is 1 hour and 32 minutes. So we're at about 58 degrees Celsius over here. Once the lid is closed, it goes a little bit faster in terms of temperature, reaching temperature and so on. I have left it here open just so that you can see it. There it is. Now it's going to go from the corner, and it should start any second now. It's doing an initial injection, and here goes. So it first does one line just to get the flow of the filament in a uniform fashion, and that's going to start printing. Now, one of the nice things I mentioned is that this has a webcam in the front of it. So let's go and see if we can launch the app from an iPad or an iPhone or some kind of a mobile device, so we can take a look and see if the camera works, and we can monitor from the camera as well what's going on the print area. And let's see what kind of features the app gives us. And here's the app running on my iPad here. And the app is probably the only frustrating part of using this Sindoh's ecosystem. And because the app doesn't always find the printer, you have to try a couple of times and then eventually it connects. Sometimes it works the first time, sometimes it doesn't. But once it works, then it does. It gives you about 1 frame per second view of the printer itself. And as the bed lowers, you can see more and more of it. So the head is obviously moving around and is starting to print. It's just the very beginning of the print right now. Here's the moving mechanism. And at the bottom here, you can see how much PLA you have left, what it is that you're printing, temperatures, and of course you can cancel the print. Being able to cancel the print remotely is very important, because if you're monitoring this and you see that there is a problem or something has come loose and it's just printing gibberish, you can quickly go ahead and cancel the print to prevent stuff from building up inside the printer. So yes, the app works. It's good to have it, and if it's connected on the network, you can just pretty much pick it up from anything. So from that point of view, I think it's okay. So here's an example of a really challenging print that I have done here. I've particularly designed and printed this to test the printer's capability under some extreme conditions. Well, first of all, as you can see, this structure has really extreme aspect ratio. It's very thin and very tall. This is 6 inches tall. So this really pushes the printer from a couple of aspects. First of all, I had to check to see how the bed adhesion would be, with the software automatically choosing the minimum kind of raft it can. So it designed this tiny little raft, and of course this has been good enough to print such an extreme dimension in the Z-axis, having such a narrow footprint. Now the other thing is that if the bed is not perfectly level, and if there are inaccuracies in the Z-axis movement of the head, that accuracy is going to matter a lot once you're really far away from the bed, because the bed is leveled with the head essentially touching it. So even if you're a tiny bit off, as you increase in elevation, that error accumulates, and then you can be completely off where you think you are, and the printer would essentially be slowly diverging away from the straight line. But as you can see, the result is really quite incredible. I mean, look at these things. These things are almost perfect. I see some minor variation in the surface here, and that's because as the printer gets further away, there are obviously going to be some inaccuracies, but it has maintained an extremely good accuracy and flatness over the entire structure. Now there's also a little curvature at the end here, so we can see that indeed the bed will, the head will perfectly track this, and it's produced a very nice smooth circular path there. Now the other thing that really pushes the printer in this case is printing two of these next to each other, or even more. When you print only one, the head will essentially travel only alongside of the structure. It never has to go away from it in any direction. But if you have to print two of these, it has to jump back and forth between them, printing very narrow pieces, which means that the retraction of the head has to be very accurate, because if it's not, you're going to get stringing between the two of them. Now I see some really small residue of stringing, but it's really nothing. It's almost, you can't even feel it really against the edges. It's tiny. And the reason that matters is because not only it has to retract, but also it needs to refeed the filament when it gets back and forth between these two structures. So the fact that it can print this so well, I have to say, is quite impressive. Now, I haven't tried this on other printers, but I've seen other people basically try similar structures, and this is one of the toughest tests you can do for things that have very extreme aspect ratio. Now, the reason you would want to print something like this is that because when you have a curvature like this, you really have no choice. I can't print this on the flat surface because it's got the curvature that extends in both directions above and below the surface of this line here. So you cannot print it on any other surface except the edge there. So if you need to print something like this, you have no choice. And to see that the printer can do such a good job, it's quite amazing. Now, these things are also fairly flexible. So when the printer is at the very top and it does this jerky movements, it has to account for that and has to have, the proper deceleration and so on to be able to make sure that these things aren't just vibrating like crazy when the head is all the way at the top. So I have to say, it's really quite good. Now, some of the coolest items you can print from a 3D printer are the ones that come out of the unit with moving parts, and here is a couple of examples of these. The first time I took this out of the printer, I couldn't believe it because it was as smoothly moving as you see here. I have done absolutely no changes or modifications to this when I took it out of the unit. Now, this is not even, you cannot even disassemble this, and this is a really tough piece, and the fact that it comes out like this is amazing. And the way it works is this actually has fully enclosed links here, and there's a rod that goes through it, so it prints it flat like this coming out of the bed, and when you pick it off, it just moves. And the fact that it doesn't have any friction, or that you don't have to break the pieces to get them moving, is because of the precision of the individual layers. Of course, you can imagine if the rod and the ring have even a tiny bit of connection and misplaced filament between them, it would not have this smooth movement. So to see that come out like this is quite nice. Now remember, this is not full, this is hollow. It has a fill pattern. We'll talk about that in just a second, but it came out perfectly, and I printed many of these because everybody who saw one wanted me to print one for them, and they all came almost identical. You couldn't tell the difference between which print was when. And similarly to this one, this dinosaur also has a fully flexible joints, and if I hold it like this, you can see the loops that essentially go between the different segments, and you cannot separate this one either, and this one even sits upright like that, which is really cute. And this one is a bunch of gears. Now the gear one is a little different because the shafts around the gear are actually connected to the gear when it comes out of the printer. You have to press it down and it will snap off, and then you have a free moving gear. The tolerance separation here is much smaller than for the other pieces, so that's probably one of the reasons why it has to have that. But this is not straight piece, right? This is a curved piece, and it is completely smooth. Very impressive to be able to get something like this out of the printer. And it's amazing that we live in a time where you can buy an instrument that does this and put it on your desk. This would have been like a dream 10 or 15 years ago. And if you have something more functional rather than just a toy, you can of course print these type of structures. This is a dispenser for solder paste like that. Now, one of the limitations of printers is that when you have different shapes like this with totally different patterns and heights and everything, people sometimes have to print them one at a time, because as I explained earlier, when the printer head moves between different objects in different directions, you get stringing. And if you have items that need to be moving over each other, stringing and bumps and surface imperfections basically can completely ruin the part. But if you look at this one, it is, I mean, it's just incredible. Look at this. I mean, I have done no modification to this. This is exactly how it came out. It's really impressive that you can get such a precision. And of course, then you can assemble this and get yourself a nice dispenser. And it fits perfectly over this. Is the standardized size. You put that over here, and you put this over here. And of course, then you pass the rod over it. And then you got yourself a dispenser, which works immediately out of the printer. And the fact that you can print it all together is important, because that saves you a ton of time, because you're printing everything at the same time. You don't have to print multiple times. So I really like that. So in terms of moving parts, moving objects with joints and things that fit together, it does a really good job. Now, something that's really hard to print without customizing the settings of the printer are objects that have holes in them. And the reason is because the retraction rate of the filament and the speed in which prints the holes over the solid areas is something you can fine-tune to improve the quality of the holes. Now, to make matters worse, this particular shape has also these structures which are almost hanging completely freely in the air with almost parallel angles to the printing plate. That makes it even harder, because there are no supports, and that would make it challenging for pretty much any printer. And it has done a really, really good job. There are some areas over here, which I can zoom in a little bit, that it has had a little bit of issue. You can see there's some stringing through it. But again, remember, these are default settings. I have made no changes to these settings. It's exactly like you see coming out of the printer. If I were to modify the settings, I'm sure I can get this much better, but then those settings would only apply to this print. So if something's very critical, you can always do that. But for default print, it's done an amazing job. Remember, this thing is hollow. So these things are floating. When it's being printed, they're over the air. There's no support. So to get these out like this is quite good. Now, for very sharp angles, or between some critical angles, it's going to get some roughness here. It can't print very well on those angles, but I don't know if there is any printer that actually can. But look at how smooth this one is, because this is also hanging. It's open. I see this is the angle we're talking about here. So it's printing this angle over the flat surface at the bottom. So it's doing quite a good job. Same with this. This is completely hanging over the air with the eye opening, and the roof here, the ceiling of the head over there, as well as these ridges, which are basically over the air with holes in them. This is amazing to be able to get this directly out of the printer with no changes. Here's another example. I specifically stopped the print at the top so you can see through it. You can see some letters hanging in the middle. These holes are looking fairly nice. This thing was supported like this. So even with tiny supports, I was able to print something like this over the bed. Now, if you have, again, multiple filaments, you would be able to print these with different colors on the inside. It's a very tough structure, even though the top of it is missing. So it's done a fantastic job. This may not seem like it, but this is a really impressive print to get out of a printer with no modifications at all to any of the settings. And of course, mixing materials is obviously possible. You can print structures with opening in them and then insert any kind of other structures in them, metals or other types of plastic or wood or whatever you want. That's one of the strengths of being able to 3D print things and then assemble higher order structures. The letters, you can see, have come out quite nicely. This hole for the dot on the eye is tiny, and it's still managed to come through very well. Different depth of triangular shapes come out really well, and it works. So I have to say, very nice. I can see there's another example. So this is not just a fluke. You can see the eye also coming out. It's really, really small. So pretty good. I like this one. Now, most 3D printed objects can take a long time, 12 hours, 24 hours, even multiple days to print if it's really intricate and large. So here's a couple of examples of this. This is about 12 hours, and it's very nice. You can see the structure came out just perfectly, even though it has so many sharp angles. It's totally waterproof and it doesn't leak at all. So it's a very nice vase. I'm very impressed with the print quality of this one. And something that took over a day, this little marble game. It's very nice also. It's designed by someone else, obviously. You just drop a marble in there and it goes through all the layers and comes out. The surfaces are totally smooth. Even the hanging regions with absolutely no support are completely smooth. Look at this. This is a sharp angle over here. So yeah, it looks very good. And of course I printed this only to realize that I don't have a marble, so I can't even play around with this, but it works very nicely. and at the bottom totally flat. Of course, this is on the surface, so it's printing it in this direction as the z-axis, and with all these different smooth surfaces, came out beautifully. And also stuff that has very thin walls again. This is a cable storage system. You can see very thin walls. This is over 6 inches tall. Some variation in texture. The reason for that is because there's actually a label here. So the only imperfection on this one, this is probably the only print I did where I wasn't completely happy with the surface finish here. You can see it's a little thinner on this one. I think the reason for this is because I printed this after many prints and I didn't re-level the bed, and I think the bed wasn't perfectly leveled once it got past here, so you see some imperfections there, but nonetheless really solid and very equal and nice distances. This is a stackable structure, so you can have them and then put probes and stuff there. It's very nice for an electronic lab if you have many probes and different kinds of cables you want to store. Very cool. Now, something that's often hard to appreciate and to observe is the internal structure of a printed object. Now, this is a thick piece, so it's obviously not solid, and the way it's filled inside, it's up to the designer. So you can say, I want a hexagonal pattern, I want a random pattern, a crystallized pattern, and it will fill the inside of the object. Now, that's going to determine how tough it is and how much it can resist different types of forces, rotation, pressure, and shearing, and all that. So I wanted to see how good it does in the internal structures when you identify what you want to print. So one way to do it is to cut it and look at the inside, but the other way is to x-ray it. Now I have an x-ray machine, so we can print two identical of these dinosaurs with two different fill patterns, x-ray them, and compare the x-ray and see how well the printer handles the internal structure. So let's go put it in the x-ray machine and see what happens. Okay, here's the x-ray machine. Let's go ahead and put one of these in here. And we can go ahead and take a couple of x-rays and compare the results.
And here's the x-ray of the two dinosaurs I printed right next to each other. And you can see they look completely different. The one on the left here uses a random fill type, meaning that every layer the fill is in a different location. So obviously as it builds up the dinosaur all the way to the top layer, it's going to have this randomized internal fill. Now it's not 100% fill, but when you x-ray it looking from the top, it's going to look very uniform. This means that the printer did a very good job at doing a randomization and filling the internal structures very well. This is important if you're looking for a specific type of strength against a particular type of force being applied to the item. The dinosaur on the right, on the other hand, is using a regular honeycomb fill pattern, and you can see the honeycomb pattern very clearly in the x-ray as lines going parallel to each other or perpendicular to each other depending on which orientation you're looking at it. These lines that you see coming out from different places, this is due to the very first layer, as there is retraction happening and not being able to perfectly get the filament out, and the first layer going very slowly to create the bed and so on. Some of the imperfection is because of that, but that's on the inside of the object, not on the outside. So the outside looks completely smooth. You can also see the little places where there is a rod going through with a hook at the top, so you can see how the structure of the dinosaur is actually made. The differences between the left and the right side shows how well the printer behaves when you choose a different fill type. So I'm happy to see that it's working very well, and you can only see this really if you x-ray this and put them side by side.
What I really wanted to print were microwave components, and of course on my channel that's the kind of stuff that we want to try. And I wanted to try something in the millimeter wave range, so above 30 gigahertz or so. So we tried experimenting here. So this is a bandpass filter centered around 30 gigahertz or so. You can see it has tiny structures. I printed multiple versions of this, one of them which is cut in the E plane, one that's cut in the H plane. Now of course PLA itself is not going to make a microwave filter, so what I had to do was to metalize it somehow, and I tried to use this. This is what they use for shielding. Essentially it's copper silver coated particles in a spray format, and once you print it you get a very nice conductive surface. So I tried using that on some of the stuff that I printed. One was a filter, the other one were these horn antennas. Now if you ever try and buy a horn antenna, especially in let's say these form factors above 30 gigahertz, they're actually quite expensive. Here's a waveguide to coax converter, which is of course not printed, but this is printed itself. Now there's a nice connection between this as well as the body of this. This is a pretty sharp angle again because it's printed in this direction, and we can see some issues in the printing the edges, but on the inside surface it's very nice and smooth, and I just spray painted it. So now the question is, well, do these actually even work? Well, why don't we measure them? I want to measure the gain of these horn antennas, and then I want to measure the combination of the filter and the horn antenna together. You can see here this is completely printed except for the screws that connects them together. This is a fully 3D printed part. So I'm really excited to see if they actually perform, and we have all the equipment to do measurements on these. So let's go to the lab and do some measurements and see how they work. So now that we take a look at the horn antenna and the different printed modules that I have, we have to measure them to see how they perform. Now the measurement setup is a little bit complicated, so I'm going to explain that. At the far back, I have a synthesizer that's sweeping between 14 gigahertz to 16 gigahertz. There you go, you can see that. It's going to sweep that across about 100 seconds. And I'm going to pass that to an amplifier module, and this amplifier module is able to control and provide power to this microwave multiplier. And this multiplier is a ×2 multiplier, meaning that the 14 to 16 gigahertz signal is going to translate to 28 gigahertz to 32 gigahertz. And as you can see, a little printed horn antenna is directly sitting at the output of the multiplier. So that's going to transmit CW waveform out into space. I'm going to use another 3D printed horn antenna on this side. There it is, you can see it's connected right there, and that is going to get converted to coaxial, and it's going to go into an external mixer, and that mixer is directly connected to our spectrum analyzer, and that's going to allow us to make a wireless link between two horn antennas. And you may ask yourself, well, why would you do it this way? Well, the reason is because by having two horn antennas on each side, and by knowing the distance between them, assuming the horn antennas are identical, we can calculate the free space path loss, and knowing the power of all the ports, we will be able to measure the gain of each antenna, which is the purpose of this. So right now the signal is sweeping from 32 gigahertz down to 28 gigahertz, and it's going to be on the spectrum analyzer. So let's go ahead, take a look at the spectrum analyzer, and see what kind of power we're getting. And here is our received signal. You can see that it's sweeping between 28 gigahertz to 32 gigahertz, and we're going to watch this go across the screen. Now, I want to see the channel uniformity, the gain of the antenna. Now, there are a lot of variables on top of each other, so we're going to only do some estimation because we're not interested in making, precise measurements. We just want to get an idea to see how well these horn antennas are working. So instead, I'm going to put this on max hold. I'm going to wait until this builds a nice trace on the screen, and then we'll take a close look at it. And here we have the completed waveform, and you can see it's reasonably flat. This drop that you see here is from the transmitter and the multiplier. This is not from the antennas themselves. A little ripple is to be expected. This is only a constant correction of the mixer. There is also multipath and some impedance variations from the antennas themselves. That's going to give you a bit of ripple. But if you look at 30 gigahertz, we're receiving about minus 30 dBm. That includes the mixer correction. The distance between the two antennas is an equivalent free space path loss of about 61 dB. So you take all of that into account, and the transmit power being roughly about 1 or 2 dB, which means that the antenna gain is about 15 dBi per antenna, which is pretty good considering that we just 3D printed these from just a very simple model, and I just sprayed them, and they're giving fairly good performance. So I'm quite happy with that. So now that we have this measurement, the next thing is to measure our filter and see how the filter behaves and see where it landed in the frequency spectrum. I'm very curious. So let's go mount that and measure that. And here's the combination of the filter and the horn antenna together. So now we expect to see the overall response, which is a combined response of both of these two guys together. Since we already measured the horn antenna, we can extract the performance of the filter directly in this wireless setup. And here's the response of our filter. Well, it's not the greatest filter in the world, but indeed it does work. You can see we have a bandpass response, which is exactly what we would expect to get from this structure. So yeah, I'm quite happy with it. You can clearly see that it has a good, I would say maybe 10, 20, 25 dB of rejection. Some of this is, it's ripples around from multipath potentially on mismatches, but it looks fairly good for completely uncorrected waveform. So indeed, we can print different kinds of even millimeter wave modules using this 3D printing and metallization process, and I look forward to creating even more devices like this in the future. And there you have it. I hope you enjoyed this extensive review of the Sindoh 3DWOX 1. If you have any suggestion for other kind of microwave devices that you want me to experiment to print and do measurements on, let me know. I really like this machine. Like I said, it's been sitting on my bench for some time and I've been using it regularly. I've been happy with the prints, and I'm eager to see what you guys think about it. Let me know in the comment section.